So from the previous video, we learned how to break sorts, okay, into how to break box sorts like these, are big numbers like this, into smaller sorts. So we can easily simplify them, okay? So here we have root 224. If you break it down, remember as you're breaking it, one of the numbers has to be a perfect square. So if you break this down, you have root 16 times 14. Then if you break 126 sod, if you break it into pieces, you have root 9 times 14. And if you break 56, you have root 4 times 14. See that? Then if you decide to solve this one in component, that is fine. You can decide to split them in pieces if you want to show full working. That is root 16 times root 14 minus root 9 times root 14. You see that? So minus root 4 times root 14. Then let's evaluate the perfect square. So we have root 16. Definitely the answer is 4. So 4 times root 14, that is 4 root 14. You keep that. Root 9 is 3, then root 14 minus 4, the root of 4 is 2, then also root 14. Now, all of these are like terms. Why are they like terms? Because they all have root 14, root 14. So it's as if you're adding 4x, you're doing 4x minus 3x minus 2x. So the same way, 4 root 14 minus 3 root 14 minus 2 root 14. So leave the root 14s and then subtract the whole numbers. So do 4 minus 3, that is 1. 1 minus 2, that is minus 1. See that? 4 minus 3, that is 1. 1 minus 2, that is minus 1. So you have minus 1 root 14. But then, you know, minus 1 root 14 is the same thing as minus root 14. So if you also write minus 1 root 14, I don't think there's any problem with that. So that is that, very simple. Then the second one, you see root 6. Root 6, if you break it down to 2 and 3, 2 is not a perfect square, 3 is also not a perfect square, so leave it the way it is. So root 6 times, then 8 can be broken into root 4 times root 2. If you break 10 to 5 and 2, 5 is not perfect square, 2 is not perfect square, so leave root 10 the way it is. Then root 12 can be broken into root 4 times root 3. So let's see what we have now. We have root 6 times root 4 is 2. So 2 times root 2, that is 2 root 2. We keep that, times root 10. We didn't touch that. Times root 4 is 2. And then root 3 beside it has 2 root 3. Okay, so in this case, we are multiplying. Okay? We are multiplying. So if you're multiplying, you multiply the whole numbers, then you multiply the surds. Multiply the whole numbers, multiply the surds. The whole numbers are 2, and these 2 here. So we have 4. We keep that outside. That is these 2 and these 2 that are here. So we have 4. Then root 6 times root 2, that is root 12. So let's write that first. So root 6 times root 2, that's root 12. Root 12 times root 10, that is root 120. Root 120 times root 3, that is root 360. Let's do it again. 2 times 2 is 4. Root 6 times root 2, that is root 12. Root 12 times root 10, that is root 120. The root 120 times root 3, that is root 360. Now this can be broken down further, so we have 4. You can break down root 360 into root 36 times root 10. You can do that. So we have 4 multiplied by root 36 is 6, then times root 10. Then multiply 4 by 6, that will give definitely 24, and then root 10. So that is that. And then the last question here, we have root 3, we have root 24. So in this case, it's very simple. You can cancel out. Now let us see the common factors now. 3 can divide 24, you know, to give us 8. So the same thing, root 3 can divide root 24 to give us root 8. So root 3 can divide root 24 and give us root 8. So let's see another one I can cancel out. Root 13. 13 is a common factor between 39 and 26. So root 13 can reduce root 39 to root 3 and reduce root 26 to root 2. Okay, let's try what we have now. At the top we have root 18, then multiplied by root 3 only, and at the bottom we have root 8 multiplied by root 2. So let's see how can break it down further now. Okay, root 2 can divide 18 and give us 9. So root 2 can also divide root 18. So root 2 will reduce root 18 to root 9. Then is there anything that can reduce each other there? Nothing. So I now have root 9, which is a perfect square, times root 3 over root 8. So let's evaluate this. Root 9 is 3 times root 3. At the bottom we can break root 8 into root 4 times root 2. So what do we have? At the top we have 3 root 3. At the bottom, root 4 is a perfect square, that is 2 root 2. But then when you have this, when you have an expression in this form, please don't leave the denominator in surd form, okay? Try to make it a whole number. And you want to make it a whole number, you must clear the surd. And how do you clear the surd? You multiply both the numerator and the denominator by the surd at the denominator. So let's see. So you have 3 root 3 over 2 root 2. Multiply the numerator by root 2. Also multiply the denominator by the same root 2, so that this very surd here will clear. Okay, so let's see what we have now. 3 root 3 times root 2 will give us 3 root 6. Remember, multiply the roots together, the whole number separate, the roots together. Then at the bottom we have 2 root 4, and root 4 is a perfect square, so we have 3 root 6 over 2 times 2. And what would that give us? That would give us 3 root 6 over 4. So you can leave your result in this form. You can also write it as 3 over 4 root 6. Whichever way you want to leave it is okay. This is okay, and this is okay. So practice with some questions to see how where you will get with it.